Alright guys, section 5.5, exponential and logarithmic equation inequalities. First of all, let me remind you that you must know your rule of log perfectly well as the rule of exponent. And it's not by solving the problem you will remember them. It is by taking a piece of paper and write your rule of log 10,000 times if it's necessary. In the example number 1, you can see that we tend to try to solve 5 to the x equal 9, and usually what we try to do is transform 5 and 9 to be able to have both sides of your equation the same base. But with 5 and 9 it's not possible. Therefore we are going to use the log, and we are going to take the log of the left side and take the log of your right side. When you take the log of your left side, you can use your rule of log, which say that when you have a log base, whatever the base, so I'm going to take the log base c, but right here when you're taking the log, just log, it's log base 10. Remember, repeat always in which base you are. Of a to the b, well, that is going to be equal to b log base c of a. So this is why we end up to have x log 5, log base 10 of 5 equal log base 10 of 9, dividing by log base 10 of 5 both sides, and we end up to have x equal log base 9 over log base 5. It is the same idea for the example number 2. The only difference is at some point I will have to distribute, because what I'm looking for in the example number 2 is trying to have all the variable on one side of your equation, and on the non-variable on the other side of the equation. And for that, I have to get rid of the parentheses, and for that I have to distribute log base 10 of 7 and log base 10 of 10. By the way, I would like to remind you that when you are dealing with log base a of a, one of the property is saying that it is equal to 1. So having a log base 10 of 10 is super nice, because we know we are having x right away. Okay, so right here we could have wrote right away x. Therefore, when we right there, we could have that equal to 1. Example number 3, we're having the same idea. Okay, we first pretend that 2 to the x equals 6. We solve x. Then when we are able to solve x, what we are to do is pretty simple. A number line. My 0 is right here, so 2.585 is on this side of your number line. I'm defining 2 intervals. In each interval, I'm going to take a value of x. Let's take x equal -1, and let's take x equal, oops, the interval is not here, making a mistake, sorry guys, but from the value of x, you have an interval right here. So sometimes it can happen. So right there, because x equals 0 is in the interval number 1, why not take x equals 0, and why not take x equals 3 right there? Then the only thing what I need to do is substitute value of x equals 0 inside my inequality, and check if the value I have will be greater than 6. If I plug x equals 3, is it greater than 6? Well, when x equals 0, it's not greater than 6, so that is a no. When this one is a yes, because 2 to the 3 equals 8, and 8 is greater than 6. Therefore, this is how we are able to define the fact that the interval notation is going to be 2.585 plus infinity, always a parenthesis next to plus infinity, and we're having a parenthesis because it's greater than, there is no equal, next to 2.585. In the example number 4, first of all, what we're trying to do is use the rule of log. This rule of log for the left side, right there we have log whatever the base of A plus log whatever the base of B, and we know that it is equal to log of A multiplied by B. Therefore, in your case, we're having log base 2 of x minus 1 times x minus 5. We're distributing FOIL x minus 1, x minus 5. And now, the only thing we need to do is we can equal definitely x squared minus 6x plus 5 equal 4x minus 1. We end up with a quadratic equation that we can try to factor if it's easy to do it. Otherwise, if it's not easy to do it, we can use the quadratic formula. So don't forget the quadratic formula, which is going to be x equal negative b plus or minus the square root of b squared minus 4ac divided by 2a. So remember to properly define the value of a, b, and c. And if I want to define properly the value of a, b, and c, in that case, a equal 1, b equal negative 1, and c equal 6. Example number 5, same idea, using my rule of log. Now we're having log of a minus log of b, and you know that log base 10 of a or base c of a minus log base c of b, it's equal to log base c of a divided by b. Now, sorry for that. Now, what we are going to do is the example number 6, same idea, it's an inequality. So, first of all, I'm going to pretend it's equal, instead to have an inequality, I'm having an equation. I find the value of x. And like previously, when I find the value of x, I find x equal 12. So therefore, I'm supposed to graph my number line, position the value 0, and I know that 12 is right here. And technically, I'm supposed to say, hey, you know what? Now I got two intervals, and I'm going to take a value of x equal 13 for the interval number 2, and I can take any value of x. Oh, because 0 is on this interval, why not x equals 0? The problem is I can't take x equals 0 because I must remember that x minus 2 has to be greater than 0. So x has to be greater than 2. So I know that obviously, if I have to look at a value, this value needs to be greater than 2. It cannot be less than 2. So let's take a value x equal 3. Okay, so when I do that, I end up to have, for the interval number 1, when x equals 3, I end up to have log of 1. And when I look at x equals 13, I end up to have log of 11. Well, remember that when what you're trying to do is check, it is checking if the value of x and the interval you are in is going to be able to be okay. And the example number 6 show that that is not okay. But the example number 1 is okay, yes, for any value in between 2 and 12. Just right here. Okay? And I know that I need to use a value x greater than 2, because if it's not greater than 2, I will not satisfy the fact that x minus 2 has to be greater than 0. Therefore, this is why I end up to have the interval notation 2, 12. Why do we have a parenthesis next to the 2? Because x has to be strictly greater than 2. Why do we have a bracket on 12? Because x equals 12, and 12 is a solution. Alright guys, so let's try to work on this example number 1. Well, on this example number 1, what I can do is take the log base 10 and be in the base 10 of 7 to the x equal log base 10 of 12. I'm using my rule of log. X log base 10 equal log base 10 of 12. X log base 10 of 7 equal log base 10 of 12. I divide by log base 10 of 7 both sides and end up to have x equal log base 10 of 12 divided by log base 10 of 7. I decided to put myself in log base 10, but if I want to be in log base 7, I could have wrote x equal log, oops, let me write that in another way. I could have wrote x log base 7 of 12 divided by log base 7 of 7. Knowing that log base 7 of 7 is 1, I end up to have log base 7 of 12. Now, example number 2. I'm going to be in log base 10 because it's easy. I don't have to write the base, but I must not forget we are working in a base 10 of 2 to the 3x plus 1 equal log base 10 of 3 to the 4 minus x. Using my rule of log, 3x plus 1, I'm using my parentheses log base 10 of 2 equal 4 minus x. I'm using my parentheses log base 10 of 3. I'm distributing 3x log 2 log base 10 of 2 plus log base 10 of 2 equal 4 log base 10 of 3 minus x log base 10 of 3. I'm going to reorganize to have all the variable on one side and all the non-variable on the other side by adding x log base 10 of 3 both sides and by subtracting log base 10 of 2 both sides. When I do so, now you can easily see that I end up to have 3x log base 10 of 2 plus x log base 10 of 3 equal 4 log base 10 of 3 minus log base 10 of 2. I can factor x. 3 times log base 10 of 2 plus log base 10 of 3 equal 4 log base 10 of 3 minus log base 10 of 2. And therefore now, if I divide by 3 log base 10 of 2 plus log base 10 of 3 both sides, I end up to have 4 log base 10 of 3 minus log base 10 of 2 divided by 3 log base 10 of 2 minus log base 10 of 3. I will let you do the problem number 3 as well as the problem number 4. Please remember, when you're doing the problem number 4, first you need to make it equal, then you need to draw your number line, and when your number line is drawn, you are able to define 2 intervals where you're going to check the value of x you decide to take in each interval will make or not the inequality true. Example number 5, same idea. 6, 7, 8, they're all the same. They're all applying the rule of log. So please keep positive. Stay positive like in the step number 3. You can do it and it is easy. We are at the last stretch of the semester. This is a section where you can definitely find your ability to have 100% on the exam number 5. So keep up the work and everything will be alright.